And what will happen if we call start is, of course, it's gonna run itself. Just put something to the console log, hello. We will see this hello message in our console. What will happen if we call start from inside of the start? So if you think about it, of course, we have this function definition. So if we don't call it from here, nothing will happen. It's just a function definition. And the fact that we call the function from within itself is never going to call if we don't call this function from somewhere else. So if I save that, nothing will happen. But should we call this function at least once, it's going to call itself. It's going to run this body where it's going to continuously call itself without end, which will create a loop. In this case, it's going to be infinite loop, and don't try this at home. It's going to hang the browser because the browser will not know what to do with it. So watch what happens when I save this file and the browser refreshes. I just keep getting all these hello messages in my console without end, and it's never going to stop, and the browser is confused. I may have a problem even closing the browser. So now I've clicked this close button in my browser, and the browser does not know how to stop because there is a function that continuously calls itself. So that's a problem, and often that may happen accidentally in the code that we write, because we usually have a lot of code in our projects, and that may happen accidentally when one function calls itself without end, and the user who visits your web page may end up with a browser window that they cannot even close because the browser just doesn't know what to do when code just keeps doing something and calling itself without end. It's just something to be very careful about, but also it is a very powerful technique that, when used carefully, can let you go through a tree. So for example, if you have some kind of a tree structure, how do you stop this browser? Go to the task manager and it will tell you which browser window takes a lot of CPU. And even though this function doesn't do a lot other than calling itself, it takes a lot of CPU. And we can just go ahead and end this process. You can choose the tab recursions and end the process. So that's going to actually kill the browser tab, browser window. And we can start again. But this time, to call this function 10 times, we'll just take a parameter. And when we call this function the first time, I is going to be 0. We could choose to pass I along. We can increment the I with every new call to the start function. The parameter is going to be incremented. So the second call is going to receive 1, 2, and so on. We can console log that. So if I were to just call that, it would run the function, and we would see all the messages and incremented numbers. We would see hello 0, I plus 1 would call start with 1, and we would get all those. All debugger, which will pause the browser on this line of code before proceeding. And that can help you understand how code works and how JavaScript works. If I go to inspect and the sources, it was actually trying to execute all the interactions, and we're still not stopping the code from proceeding. I'm just going to refresh the page, and now because my DevTools was open, it reacted to my debugger call. It just paused on this line. We can inspect the variables. We call the start with 0, and that's exactly the parameter value that we receive in the start. You can see all that here, and the code is paused on this line with the debugger expression. I can just press play, and what it did was it went all the way around the start. It called I plus 1, and now we have I being equal to 1. If I press play again, I'm gonna get the code paused on the same line. Now I is gonna equal to 2, and so on. I can keep pressing play. I will get the start function called here. So something else I can do is I can press this step over next function call. If I press this, the debugger will pause on the next expression right before it calls start. So if I press step over, I will end up on this line again because we don't have other expressions here. So I keeps incremented, and let's say we want to stop the recursion. If I is greater than 10, we want to return, which will stop this function from executing. I'm gonna press play and refresh the browser. I may need to open the same page in a new tab. I'm just gonna drag and drop. Yeah, so now I have the console open, and what happens is I've got the console logs all the way through 11 because I'm checking if I is greater than that means it already reached 11 here, and that's why we are getting the I here. And once again with this debugger call here, with the DevTools open, we can refresh the page and inspect the code as it works. And now we can go through all the lines, and when it reaches 11, the code is going to stop. Another way you could write that is instead of checking for I greater than the number that you don't want to exceed, you could check for I being within the limit and execute the start function that would keep calling itself only while I is within the limit. So as I save that, now as we go through all the I's, and we will see that it's going to keep calling start only if I is less than 10. If I is 10, we get the 10 here on this line, and because it reached the 10, this expression is no longer true, so it's not going to call start anymore. This recursive function, it is super useful when you have some kind of a tree structure that you want to go through. Let's say we have an object, we'll call it tree. It's going to have a title, it may have a lot of other properties. It's going to have a property called children, is going to be an array where every item is going to also be an object with a title, children, so that would be another object with a title, C, and not all of them are going to have children, just some of them. So this one is going to have 2 children, title. B and D are going to be siblings. B is going to have children and 1 child with a title of C. It is super useful to use this kind of a function to go through all the items in such a tree. Now instead of starting with the 0, we'll pass the tree and we're going to call it node, and we're just going to console log the title out of that node. So every node is going to have title, and we'll see that in the console. What we want is we will call the start only if current node has children. If node children, then we're going to call start on every child. How do we do that? We expect children to be an array. We will call for each. That's going to be the child object, which is going to be exactly the value that we pass forward to the start function. That way, we will go through all the children. Let's start that and see how that works. Seems like I'm missing a comma. and we have all the nodes in the console A, B, C, D. So what happened is that the start received the whole tree, the object with the title A, and we checked whether A object has children, and it does. There's this whole array that is there. So we went through the children array and called for each on that. So this function was called on these two objects. These two objects were passed one by one to this function, where we have the start call. Well, it is a recursive call to the same function, which expects a node, and now one of those nodes is this child that is passed to as the node to the start, and we get a console log of that, which is title B. That's exactly what we get in the console, node B. And then something interesting is that we get C before D. Is that before going to the next one, after we got the B, we immediately checked whether this B node has children, and it does. So it went further down into the B before proceeding further to the child of A. Because this B has children, we went through the children of B and received the C object and passed it as the child to the recursive call, the start. So now we immediately got the call for the C child of the B. That's how we got all the A, B, C, D calls. And then while the C was displayed here, we still have this check, if no children, because C does not have any children, nothing happened. The recursive function was not called from the C object, from the C call. But the for each that was going through the children of A was still going through the children of the A. So after it is done with all the children of B, and B could have more children, and it would go through all of them before for each that was going through the children of A received the second child. After that happened, we got the console log that is printing the D in our console. Then it checked whether D has any children, and it doesn't, which ended the script. And once again, it would be a great idea to inspect this script with a debugger. So I'm gonna add the debugger call here. It refreshed my page, and we can inspect everything that's going on here. Now this is the first call. We called the start with the tree. Tree was passed as the parameter to the start. We got a title and title A, and this object has children, so we can see how the A goes to the console, and then because it has children, B and D, it goes through them. So when I press play, pause on this line again, and now I will see the title B, and instead of pressing play, I could just as well press step over, which took me to the node children. And if I keep pressing step over, I will be inside of if. Because I'm in the node that has children, this way I can inspect how the code goes through the structure that I gave it. This is the structure, and this is the logic that I wrote to go through the structure. So now I've got C, and if I press play again, I will get D, which is printed in the console, and the code is completed.